If you walk into any pub in Great Britain and ask a group of historians, what machine actually won the Second World War, you will start a fight. Someone will say it was the Supermarine Spitfire that saved London. Someone else will argue it was the P-51 Mustang that broke the Luftwaffe over Berlin. Another will swear it was the massive Avro Lancaster bomber that crippled German industry. But they are all arguing about the wrong thing, because every single one of those legendary war-winning aircraft relied on the exact same beating heart. They didn't win the war with the biggest planes. They won the war with a system glitch in mechanical engineering. A single, relatively tiny, violently loud V12 engine that was bolted to almost every Allied fuselage that mattered. This is the story of the Rolls-Royce Merlin. The miniature engine that started as a 900 horsepower experiment survived a fatal design flaw, crossed the Atlantic to be mass-produced by American car makers, and ultimately battered the massive engines of the Third Reich into submission. To understand why the Merlin is the ultimate engineering outlier of World War II, you have to look at the math of engine displacement. In the world of internal combustion, the general rule is simple. If you want more power, you build a bigger engine. The German engineers at Daimler-Benz and BMW lived by this rule. The fearsome Messerschmitt Bf 109 was powered by the Daimler-Benz 601, a massive 39-liter beast. The terrifying Focke-Wulf 190 used the BMW 801 radial engine, a staggering 42-liter Titan. Against these absolute monsters, the British brought the Rolls-Royce Merlin. It was only 27 liters. For our American friends, that is roughly 1,650 cubic inches. In the grand scheme of aviation, it was a tiny, compact, almost delicate-looking block of metal. It was the Mini Cooper of aviation engines, going up against heavy-duty muscle cars. But Rolls-Royce engineers understood a secret. You didn't need the biggest engine if you knew how to perfectly manipulate air and fuel. Thanks to the introduction of specialized 100-octane aviation fuel developed in the United States, the Merlin engine could be pushed to extreme pressures without destroying itself. The fuel acted as a cheat code, allowing this tiny 27-liter block to generate over 1,100 horsepower early in the war, allowing the Spitfires and Hurricanes to save Britain during its darkest hour. But the Merlin was not perfect. In fact, early in the war, it harbored a fatal system error that was getting British pilots killed. The early Merlin engines used a traditional float carburetor. If a Spitfire pilot was being chased by a German Bf 109 and suddenly shoved his control stick forward into a steep -G dive to escape, gravity would force the fuel to the top of the carburetor. The engine would instantly flood, cough, and violently cut out. In the middle of a dogfight, losing engine power for even 2 seconds means you die. The Germans quickly figured out this glitch. Because their massive Daimler-Benz engines used advanced direct fuel injection, they didn't suffer from -G cutouts. A German pilot could simply push his nose down, and the British pilot physically couldn't follow him without his Merlin engine choking. It was a terrifying flaw, but the Allies didn't scrap the engine. They iterated on it. Through mechanical ingenuity, including a famous restrictor plate known as Miss Schilling's orifice, and eventual changes to the fuel system, the glitch was bypassed. The tiny engine was back in the fight. By 1941, Britain had a massive problem. They had the best engine in the world, but their factories were being bombed into rubble by the Luftwaffe every single night. The demand for the Merlin was astronomical. It wasn't just powering fighters, it was powering bombers, reconnaissance planes, and even British tanks. Rolls-Royce built engines like Craftsman. They were brilliant, but they weren't mass producers. They needed a lifeline. So Britain packed up a complete master set of Rolls-Royce Merlin blueprints and secretly shipped them across the U-boat-infested Atlantic to the United States. They needed the masters of the assembly line to save the engine. Initially, the contract was offered to Ford, but Henry Ford controversially pulled the plug, refusing to build weapons for foreign powers. Instead, the contract went to Packard. What happened next was a collision of British aristocratic engineering and American industrial muscle. Packard took the handcrafted, beautifully complex British V12 and adapted it for Detroit-style mass production. Between 1942 and 1945, Packard pumped out over 55,000 Merlin engines. The mechanics on the ground in England could instantly tell the difference between a British-built Merlin and an American-built Packard Merlin. The British engines used dull cadmium plating because of material shortages. The American engines arrived gleaming, bolted together with flashy chrome-plated nuts and bolts. The most famous application of the Packard-built Merlin was the ultimate Frankenstein experiment of the air war, the P-51 Mustang. When North American aviation first built the P-51, it was an aerodynamic masterpiece with a terrible American Allison engine. Above 14,000 feet, the Allison engine simply ran out of breath. The plane was a failure as a high-altitude escort. But when engineers at the Air Fighting Development Unit in Duxford pulled the Allison engine out and bolted the 27-liter Merlin V12 onto the front of the Mustang, they created a monster. The Merlin transformed the P-51 into a 440-mile-per-hour apex predator that could fly to Berlin, fight at 35,000 feet, and fly all the way back. As the war raged on, the German engines got bigger and more complex, moving their production into underground caves using slave labor to survive the relentless Allied bombing. But Rolls-Royce didn't need to build a bigger engine. They just needed to squeeze the 27-liter block even harder. They added two-speed, two-stage superchargers. But compressing air that much makes it boil, so they bolted massive intercoolers, radiators filled with ethylene glycol around the air ducts to cool the oxygen before it hit the cylinders. They pushed the Merlin from 1,000 horsepower in 1939 to an apocalyptic 2,050 horsepower by the end of the war. The ultimate expression of this madness was the de Havilland Hornet. It was a sleek, wooden, twin-engine fighter designed to fight the Japanese Zeros in the Pacific. It carried two of these 2,050 horsepower Merlins. Pilots who flew the Hornet described it as being so dangerously overpowered that they could perform an entire acrobatic air show, including full vertical loops with one engine completely shut off and its propeller feathered. It was likely the fastest production piston engine fighter ever made, driven entirely by an engine that started as a 900 horsepower experiment. By the time the guns fell silent in 1945, over 150,000 Rolls-Royce Merlin engines had been built. It powered the Spitfires that won the Battle of Britain. It powered the Hurricanes that held the line. It powered the Mustangs that broke the Luftwaffe, and it powered the Lancasters that shattered the German war machine. It even eventually gave way to its larger cousin, the 37-liter Griffin engine. But no engine left a legacy quite like the Merlin. Today, 80 years later, if you stand on the grass at Duxford or any air show around the world, you don't even need to look up to know what is flying over you. The crackle, the whistle of the supercharger, and the deep, chest-rattling roar of a 27-liter V12 running at full throttle is unmistakable. It is the sound of absolute mechanical perfection. It is the sound of an engine that was too small to win, but too perfectly designed to fail.